Welcome everyone to another great episode of the Do Better Dev Show. I'm here with your AWS certified specialist, Nathan. How you doing, Nathan?
Doing great. Doing great. How are you?
I'm doing great as well. I just started my job at AWS this week.
Oh, wow.
So I needed to make sure we're both somehow affiliated with it.
Right. Yeah. I was going to say I'll bring it up every time, but no promises. It's not like I feel that it even will bother you as much as it bothers me. So
it will not.
No.
Yes.
I'll find something else to annoy you every episode. It's been a while since we recorded, which is funny because I've seen you pretty much constantly for the last 10 days, but no episodes. Despite that, we did get an episode out when we were supposed to. So
yeah.
It actually caught me off guard because I'd forgotten we'd recorded it, and then it popped up in my YouTube subscription. I was like, oh yeah, we did record an episode. Nice. Good job, us.
Yeah. Past podcast people. Past us.
Yeah. We done good.
Yeah.
And so now, we're back at it. Ironically, despite the longer period of time, I'm going to have far less do better stuff to report on. So we'll see how that goes. But in the meantime, how was your week? Anything interesting,
great.
Frustrating that you want to share?
Of course. You know what? I'm going to give a little window to what we did for the 2 weeks.
Yeah.
Or at least the 1 week, or about 10 days. We explored most of interior BC. Everything that's not the Vancouver Island and is mostly part of BC because it's better over here. So people who live in Victoria and who I like should move to Vancouver. But that's a separate topic. And yeah, we drove. According to our rental car, we drove around 2,400 kilometers. And yeah, it was crazy. We saw almost too many waterfalls and lots of hikes, and yeah, just so many gas stations, food stops, smoke, fire, which is very terrible because it's getting worse now. And I have a friend who's in interior BC right now, and she sent me pictures, and it's all smoke.
Yeah, we got there just in time.
Yeah. So yeah, that's kind of sad and terrible, but overall, great trip. And yeah.
Yeah, the emergency trip over to Banff was a good idea because we were originally planning on going further north, and we drove through one area that was just all smoke and the sun was literally red. We're like, let's reassess these decisions. And so yeah, we got a little bit further east than originally planned, but it worked out, and just spent a bunch of time hanging out. I actually was at one point thinking, like, I don't really care to stop for any more waterfalls. And then the Bear Creek Falls sort of reinvigorated it. I went, oh, waterfalls can be cool, because I really liked that one. So if anybody else is in that area, just driving around and feel like stopping at a cool waterfall, it's a short walk. It's like 15, 20 minutes maybe. And it was very nice. Just make sure you have a pass so that you don't get fined for being in Banff.
Yeah, and you know, the Bear Creek Falls are mostly inclined, so even if you don't have a pass, just run really quick from the parking lot. It's inclined, but if you have the legs, you can make it back before any park ranger catches you.
Yep. Also, the pass is like $10, so it's really not a big deal to. If you're gonna spend the day in Banff, get the pass.
That's true.
That was what we were up to.
Exactly. We learned that if you decrease the incline on a mountain, trains can go faster, which is crazy. Who would have thought of that?
Yeah, fewer engines, more tons. Spiral tunnels.
Yeah.
Spinal. Yeah, I read a bunch of signs that told me so.
Yeah. It just kept telling you spiral tunnels next. But none of it were true. Or not the ones we wanted to see.
Yeah. There are a lot of spiral tunnels. We did see a train, though, going through said spiral tunnels. So it actually happened. It's not made up. But from that period of time, anything that in particular you want to call out?
Yeah. I'm sure most people maybe read about it. I heard about them, but never read about them until I joined AWS. But the robots in the warehouse, they're so cool. I never bothered reading about them, but they're just it's such a simple concept. They have all these shelves full of items, and this little orange robot is the height of a Roomba, but it's more wider and stronger. So it just goes under shelves, lifts them up, and then moves them around,
Mm-hmm.
which is like just I don't know. For some reason, it was the coolest thing to me because there's people on the other side just waiting to take things off of shelf or put them back, and all these robots are running around saying, "Oh my God, this shelf needs to be made." So if somebody ordered, I don't know, a set of pens and it's on a shelf with a lot of other random things, this poor robot is moving this entire shelf full of random things and a pack of pens to this person just so they can take a pack of pens out. And that's insane, but also really cool to me because I robotics is something I'm really interested in, and just seeing this really small use case but so efficient and smart, because they all move in diagonals. So even as a programmer, you can like start thinking of 2D matrices and how you would get from point A to B and all that, and it's just really cool.
I'm sure eventually they'll get to the point of taking things off the shelves. But it is funny
Probably.
that the solution for now is like the brute force method
Yep.
of, well, it's kind of like we need something in this register. So let's fetch the whole register out of storage, present it, fetch the item. that's the person taking the pens, and then just send it back to memory.
Yeah.
Yeah.
It's hilarious, but yeah. Anything cool, annoying, or
Oh.
frustrating for you?
Yeah, I wrote them down. I thought you were gonna have more stuff.
Nah,
Let's see.
I'm a
Let's see,
boring
let's see.
person. That's all I got. I'm
Oh, I
pretty
know.
sure
It's been
everything else I read is under NDA, so I can't talk about it.
That's true. Yeah, it hasn't sunk in for me yet that you work at AWS now. It's funny. Still repping for us, but nice.
Yeah.
All right, so I just have two things. One, I've mentioned him a bunch now, but Lex Friedman was a guest on Andrew Huberman's podcast recently, which was funny because I only started listening to Andrew Huberman's podcast maybe 2 weeks ago, and he then put out an episode with Lex Friedman, who I've mentioned a bunch on this show. So I was like, oh, a crossover, cool. And it was a really good episode. So Lex Friedman is I don't know if he's officially a professor, but he studies robotics and AI. And so it's because he's the guest, he gets to talk about the stuff he's working on. And he talks about some cool stuff where he's trying to figure out his interest is primarily in how humans and robots interact. And so he's doing experiments where he's like, he has a fleet of Roombas essentially. And he's like, if I make it so that kicking a Roomba causes it to yell in pain, what's my reaction to that? And so he just tries it, and he's like, I could hit it once, and after that I felt so bad. I couldn't do the rest. So talking about these sorts of things is really interesting. It's a long episode. I think it was at least a couple hours, but really good. So I'll put that in the show notes. And the other thing, this one was fun. I played Rocket League with friends for the first time. So got you to play some Rocket League, and it was very painful. The input lag was slightly different than I was used to, enough for me to mess up a lot. But at the same time, you'd never really played a whole lot. So it balanced out, and it was on your account, and I was guest. So it actually was probably better. It kind of nerfed my 7 weeks or 7 months of experience. So that worked out well. And then played with one of my coworkers who's been playing for years, but off and on. And so he's a little bit higher ranked than me. We played together last weekend, and that was a ton of fun because we got to go into diamond lobbies, and at the time I was plat. And this morning I got to diamond, and so now I am competing in diamond ranked games, which
Dang.
is fun because the cool thing about Rocket League is that as you get better, the opponents and teammates get better, and the quality of the game gets a lot more enjoyable. To keep it short, essentially, like when I was in gold, everybody would jump for the ball and miss, and so it made games very unpredictable. Well, it made games pretty predictable actually, because everybody just missed all the time. But it meant that you kind of just like hit it towards the general area of the net, and your teammate's probably going to miss it, and it's going to go in. Vice versa for shooting on the other team. And then you get to plat, and about 50-50, they'll actually hit the ball, which makes it very unpredictable and very hard because you're like, maybe they'll hit the ball. Maybe they'll miss the ball completely. Maybe they'll shoot it into their own net. Who knows? And now as I've gotten to the higher end of plat, low diamond, it's more like 75-80%. Or they at least know I'm probably not going to hit this, so I won't jump for it. And so the game's just getting more consistent and more fun. So enjoying that. And those are my only two things from the past week. Everything else will be in the Do Better section.
Very cool.
Yeah.
So yeah, we could. Do you wanna start talking about the topic today?
Oh geez. So we're finally doing it. Doing the episode that we've alluded to for a while now. Database optimizations. And so this is clearly a passion project of Gyan. So you're gonna run most of it. But if fair enough, or like a good unexpected thing came up earlier before this, which was I was watching database optimization and architecture videos, and then you sent me a message being like, do you want to talk about database optimizations in this episode? And I went, actually, yeah, it's on my mind, so let's talk about it. So I don't have a ton to add at this point because I'm trying to shore up this as a weakness, but maybe I'll learn some stuff and it'll point me in the good direction for more things I can look up. So I'm looking forward to it for that reason, but I just know the basics. So how about you lead us into it and I'll contribute where I can.
Yeah, and anybody who listens to this podcast, you're a DBA now.
Sick.
Yeah, send us a email and we'll send you a really badly templated certificate that's not legit at all from any angle, in a PDF form.
Okay, I guess we're making promises now.
Yeah, I'll design it myself.
Okay.
And I'll design it on some really bad online certificate generator. And yeah.
Okay.
If
Well, I guess I'll listen to this episode after we record it so I can get my certification.
You gotta hang it on the wall though.
Oh, all right.
Yeah.
I don't even have art on my walls, so I think I'll pass on that.
Okay. Well, okay. So I'll start. Yeah, I'll start giving some normal, like some context. What most of my experience optimizing databases comes from relational databases. Some of it has been just like non-relational SQL databases, NoSQL databases. So we're probably going to say the word databases a lot, and I sort of apologize for that already. And, and yeah, so it's very much things that I've actually tried and tested, things that I've read up on, and I've broken them down in rough categories, but in no way are these like successors. That's the idea. That's how I'm trying to present on try this, then try this, move on to the levels up above. But you can mix and match depending on your use case, deployment, wherever you're working. And most of these should apply to both databases, relational and non-relational. And yeah, I'll just get into it.
Yeah, go for it.
For the very first one that I'll start off with, just write proper queries. This one, and by that I'll give more. I won't leave this vaguely. It's mostly like writing your select statements. Anytime you write a select statement, select star is bad. It's good for testing. It's good for SQL visualization tools. But in your code, you should always have proper column names, whatever you're getting, so that when you do get it back, you also know the order of information that will be coming in. And you can control between API changes and database calls if you are controlling which columns you're retrieving the information from. Number two, when you're looping over information in your code, if 99.9% of the use cases, when you are fetching some information and filtering it, try to filter it at the database level, then fetching all the information and then filtering it on your code. Because databases are meant for filtering and searching and sorting, and they're much faster at it than whatever Python code you're writing to do all the filtering. So I understand databases are a little bit harder than if you're not as comfortable with SQL to write filter statements and understanding how to properly get the data you need. But I would always recommend doing that on the database side because they're meant for that and they're good for it. And then number three, whenever if your database is backing up a lot, most, if not all, databases have internal queues where they store, select, insert or whatever statements, and then they execute it depending on the load and the core queues. If you're noticing your database is getting backed up constantly, A, that's bad, do something about it. B, to do something about it, see if you can offload the queue on an external service like Redis or something where all the database events are now buffered, and then you can go insert that. Of course, it'll depend based on the use case. For financial and money level records, you may not want to queue events and process them later. You may want to do it more instantly. But if it's like user events or actions and clicks, you could probably insert them later on using some external queue.
It's always Redis. Redis is always the solution for
performance. Redis is the solution.
I couldn't help but smile when you were like, something like Redis. I'm like, of course, Redis.
Of course. You could go in a solutions architect interview and they'll just be like, do you know anything? You just say Redis and they're like, you're hired.
That's what I was going to reference that because you said that on a previous episode. You're like, just say that in an interview and you're basically hired.
It's true. It's how I hire all my teams, and that's why none of my teams exist anymore.
The secret is out.
Yeah, they're in and out just like data in Redis.
Oh, wow. They live only in our memory.
In the memory, yeah. F. And then the next one, that if you're as a beginner or even as an advanced DBA, whenever you start searching for how should I optimize my database, indexes. Indexes are the key. Indexes are best. Indexes are everything you'll ever need. But don't abuse them. It's a hot take. Indexes are there's again everything. Yeah, I stand by it. If you index properly, you could probably get away with a really small database cluster. You may just have to pay more for storage, but storage is cheap, and you can get away with a lot of like scaling performance issues and just having slow queries so long you index properly.
So long as you're a read-heavy database.
Yes. Yeah. Let's also talk about that. Most of these perspectives or things that I'm talking about are from querying, fetching, sorting, getting information back from the database. To optimize a database for writes, it's almost always get better hardware and figure out how you're inserting information in tables. Again, indexes, if you do too much of them, that's where they start causing troubles. So if you are indexing too much, all your inserts and updates are going to be extremely slow because it has to go update information all over the place. So again, it's a very useful tool, but use it with caution. That's why I always put that asterisk. If you use it right, your database will be happy, faster, healthier, anything you ever wanted it to be, really.
Wow.
Yeah. Completely no previous attachment to this style of database optimization. It's just it is it. Yeah. Have you had a chance to play around with much indexing?
Yeah, I mean just the normal stuff where like we have a query right now that sorts on a particular column that if you don't need to perform that sort, it was something like a couple milliseconds. And if you do need to, it was something like 200 times more time or something. And this is a very frequent, important query that's used on a lot of endpoints. Something like that. It's been a few weeks now since I looked at it because I had a week off and then didn't need to look at it again. But I just had to add an index to that particular column, and that pretty much solved everything. So it can be very good. Again, this was a write problem or a read problem. That column, it's a name field, and this particular thing, the name doesn't change very much. It's everything else. So there was not too much concern with updating that particular index or adding that particular index, I should say. But something we did have to take note of was this is an enormous table, and so we needed to add the index concurrently so that it doesn't lock the entire table and everything interacting with it just crumbling and as it just waits and waits and waits. So just more things to keep in mind with
Yeah.
responsible index use.
Yes, and there's like gotchas based on the type of database you're using. So like the keyword you use, concurrent indexing, not every relational database supports it, which is really sad. Last I checked, MySQL didn't. I don't know if they ever implemented it after that. It's been like 3 or 4 years.
That was a really butchered version of that name. MySQL.
MySQL, MySQL.
That's it. Yeah.
Yeah.
MySQL.
MySQL. MySQL.
Yeah, I think I've exclusively used Postgres in real world. Have you had to touch Mongo for a proof of concept on something? And that's been it. Everything else, every team I've been on so far, it's all Postgres. So that's pretty much all I know, practically speaking.
Yeah, it's all Postgres. It always was.
It always has been.
Yeah, because that's the more preferred way. It's open source. People like it. There's no licensing issues, and it's just better, honestly. Even this massive service on AWS called Redshift takes a lot of inspiration from Postgres. It's pretty much just Postgres on steroids. And it's pretty cool. It's great and it works, and you can run pretty much exact same queries with some little additional touches on Redshift that you would run on Postgres. So yeah. And then did we ever do an episode on different types of database?
I don't think so.
Okay.
If I'm remembering, correct me if I'm wrong on this, because I want to know if I remembered this correctly. From my AWS course certification, wow. I have a vague memory of Redshift because despite it being based on Postgres, is not OLTP, it's OLAP.
I don't know what either one of those keywords mean.
Okay, one's OLTP is online transaction processing.
Oh, okay.
I don't remember what the other one is.
Yeah. So Redshift is meant to be more as a data warehouse than streaming information or ACID compliance that you get from Postgres. Yeah, I'm assuming that's the difference between OLAP and OLAP. App probably is analytical processing because it's a data
Something
warehouse.
Something like that sounds right.
Yeah. But yeah, that's why I said it's like Postgres on steroids. It's more optimized for read-heavy stuff. You can put in information on 10 different ways, and then you can query them in different ways from different data sources. Like it even has hooks into S3. But this is not a Redshift episode, so I'll stop talking about it. But yeah.
Aurora is just managed Postgres?
Aurora came as an inspiration from MySQL and MariaDB, but it's also sort of Postgres. So yeah, you can think of it that way. It's their version of this is our ACID compliant RDBMS solution. Go crazy. Yeah, and to be fair, in a lot of things, it's actually significantly faster than Postgres or MySQL, but it's also commercialized.
That's their claim, right? You pay more, but you get some good returns in performance.
Yeah. And it's not open
source.
So
a bunch of some of this stuff, and if you're using a managed solution, might not apply. But writing the right queries always will. So
it 100% will, just like the previous point. Write proper queries, exactly, and make sure when you're writing them, you have proper indexes. And a big myth with indexing is it's only really needed when you're filtering information. So like if you have where clauses. But a big one that people forget that you mentioned is sorting. So having indexes on columns you're sorting will make them so much faster and better that you'll just go to bed at night happy.
And combinations really matter, right? Because it can only use, and I have a vague memory of the order mattering as well. Like maybe not.
Like on querying?
Like if you're querying and you have a certain, like say you have an index on three things. I'm trying to remember if this is accurate or not. If you have two, but they happen to be the first two, then it still works or something, but not if it's like the first and the third. Is that a real thing, or am I thinking
I
of
think
something
you're
else?
remembering it correctly. From what I remember, that was the rule of thumb because they may have fixed it. I remember there were things where they're like, oh, but this edge case works.
Yeah,
But in the beginning of times when indexing was being put on,
yeah,
the rule of thumb was you index in the format as you would query them in the group so that
yeah,
the grouping always lines up. And logically, that also makes sense to me because there is a certain way you're filtering information probably, and your indexes should reflect that. So yeah, anything on your where clause, so long you don't change the ordering, it should be exactly the same as however you index.
yeah. All right, this is fun. I've got all these half things in my brain. It's like 50% facts, but you get to fill in the rest. So I've got one other thing that I have a 50% fact on, and I want to know if it's right. Uh, if you have, say that you have a where clause that's filtering out a bunch of stuff, and then you're selecting based on a particular column that has an index on it. My understanding is there's a point at which a database like Postgres, because that's the one I know, will choose not to use the index and will instead do a sequential scan if it needs to actually I suppose select might not be right, but if it needs to sort and look at all the records, it may choose not to use the index because it's now using a subset of the table, and it'll choose to do a sequential scan to get all the records in. And when I was doing some testing for this particular query I was working on, I think I was seeing that at a certain point where it was like really performant. There was a awkward section in the middle that was quite bad, and then it got performant again relative to the number of records being returned. And it seemed like what was happening was it was almost prematurely choosing to not use the index anymore, where it still had a lot of records left in the table that it needed to search through. And so you're getting a performance hit because like, well, I don't have all the records. I won't use that index anymore. But it still had to sequentially scan through a ton because the table was really big. So does that sound like it's a real thing, or am I imagining that?
Partially. So
Okay.
uh, depending on how you were doing the join, that could be causing that issue. So if the based on the join and the table relationship, if you have created the index properly, it should always use the index. And then there are cases in which the join or the index exists on the columns, but because of how you're joining, it does sequential scanning instead of using the index because of the join doesn't reflect how the indexes are built. But
I'm
there shouldn't be a case where for the same query, it sometimes uses indexes and sometimes it doesn't based on the amount of records that exist in the database. That shouldn't be affecting
I don't know, but okay. I'll take your word. You're the resident expert in this conversation, so I'll take your
the
word for it.
self-proclaimed expert. But
That's right.
yes.
Of the two of us, you're the self-proclaimed expert.
Which leads us into our excellent third point. Once you've
What's that?
indexed things properly, join properly. uh, this one mostly applies to relational databases, not NoSQL, but oh my god, joins are even now I can't get my head wrapped around them properly. Every time I do it, I Google SQL join, and there's this really nice chart with all the different joins in it.
The circles look great.
Exactly.
Yeah, and
The
I'm like, oh, I get it, but then I go to do it, and I don't fully get it.
interesting. I guess I empathize mostly because I have the similar problem, but if I don't look at them, then I feel worse about my query than if I do look at them. Like, okay, I'm making somewhat of an educated decision here.
Yeah,
Yeah, and joins are great. They're, joining is what brings people together, literally.
and tables.
And tables and things and unions and marriages. And, if you can join two people in marriage, you can join tables properly. And unlike marriages, table joins rarely fail if you've done them properly. Uh, I'll slowly just go past that point. But yeah, the thing I want to mostly point out about joins are some of the premature mistakes of people using tables that don't really need to be in there. So if you have to join table A through B through C, um, really reevaluate how you're doing things. There might be an opportunity here to normalize some of your data. And before any of this information that you're doing, like anything that I've talked about in this database optimization episode, when you're creating table, that's when you should be normalizing them. Normalization is like the first step of figuring out how to design your schema and structure, so I didn't talk about that much here. So I'll just assume your database is fully properly normalized before you do any of these things.
So normalizing, that's the foreign keys to everything, right? And denormalizing is duplicating?
Sort of, yes. Yeah, sometimes you deduplicate data to provide better searching and information scans, and like faster querying and faster insertion. But you normalize data bases or tables to ensure structurally they make sense and your data is logically grouped into proper places.
Yes. Okay. So I was following that. I was missing the part about how normalizing our data was going to help, but I may have just misheard something.
Yeah, so normalizing the data will help on joins because then sometimes let's say two tables have similar data. Let's say you didn't normalize them, they're denormalized. You have two sets of pretty much identical data and there's only one column you need. So now you're joining them in a way that is slowing down everything because you didn't normalize your tables and now it's in a bad state and now you don't like it and your inserts are slow because you're duplicating information and the joins are bad because of however you're choosing to duplicate information. A lot of times in situations like that, you really benefit from like just having individual unique data and then having a foreign key table where it just tells you what's the joining columns between the two to help facilitate those queries. This one's a little, because how joins work and how real world works, you may run into sort of bring your own, choose your own adventure kind of thing. But for the most part, if you've normalized your data properly, joins are less of a pain. Especially when you're using a table which is not a join table just to get a key to get to another table. That's when it sort of starts smelling like a database smell, where because of how you get to, I don't know, some customer's demographic data, you have to join customer to something else to get the customer information. So it'll be like some intermediary table holding the demographic data, but that data doesn't exist with customer, even though it should because it's customer data. Yeah. You look confused, so that's why I'm stopping.
Yeah, so are you talking about having like lookup tables in between the two?
Yes.
Because I really only think of using those typically for one-to-many relationships or something, or even many-to-many, where you're like, this user, if this user has one profile, then sure, you can have like users and profiles, and you can foreign key that if you want to keep that data separate, but at least it's a one-to-one, easy to follow. If you're using an ORM, it'll end up being something like user.profile. There you go, you're done. But yeah, if you're doing like user profile ID and then a table that has the lookup table that one column's user profile ID and one is user ID, that's kind of insane. But if you're doing something like, languages spoken for that user, and then you've got a table with a bunch of languages in it, then you might want a crossref table in between them where you can say, all right, let's look up this record that points to this record and it also points to these other records, and it gives you a chance to do a one-to-many like fan out sort of strategy from one row in the users table that can then look up a bunch by essentially saying like it would be users and then language, and you would have multiple records for that same user ID in the lookup table, and each one would point to one individual language in the language table. But the result is that one user ID has many languages
Yeah.
to use Ruby syntax, or I guess Ruby on Rails verbiage, which you're gonna love.
I'm already looking into it, and yeah, 1 week of doing it, I'm like, no, this just, I'm happy I never touch it, but I guess I'll have to. So
Yeah.
I'll be writing CLIs in it though, so not APIs and everything, so it should be easier and less
Sure.
headache. But yeah, but
Yeah.
not to derail, what you described are how xref tables work,
Yeah.
and that is the correct usage of them, and that is how you should be building them and doing joins on them properly.
Okay.
The
Good.
situation
As long as what I said was correct.
Yes.
I thought I was misunderstanding what you were trying to say. So if
No.
those two things line up,
Yes.
then we're in agreement.
Yeah.
Good.
And that's because that's good database design. That's how you want to design these things. If you have a one-to-one relationship, you don't want a cross-sub table because that's makes no sense.
Yeah. It just makes life hard.
Yes, exactly. And if you want a hard life, I don't know. You're already in software dev, If you do you really want to make it worse, maybe pick up JavaScript and Ruby. But yeah, so and another things like remove unused tables. When you're doing subcoring, do them properly. There's a lot of issues, and I don't know if I can properly describe it in words without like showing two different SQL query examples. I'm sure if you Google, you'll find out on properly joining through subqueries. But yeah, because a lot of times when people are joining two tables, instead of using proper joins, they'll just say, select whatever and on this column. And what that does is it does sequential scans and joins individual for each row. So if for the customer and orders table, it'll go for each customer for all the orders, then the other customer through all the orders. And if you join properly, it'll at least get the intersection, put them together in the same area, and then you're working with the smaller filter data subset, which will make your queries and database happier, cleaner, and nicer.
I have another 50% fact bag memory, and I don't remember what these were called. They might have been like computed statements or something like that. But they were, when I was writing a lot of ETL stuff, there were these statements I could use that were, as far as I could tell, a way of running a subquery, more or less, that you could then reference in the actual query that would not do a repeated lookup, because it was kind of like saying, prefetch this data, store it in this statement that I've called this, but you're really storing the result, not the statement itself. And then you can use that as a reference. So if you were to like gather up a bunch of IDs and then use them in your, statement some other way, it would not repeatedly run that query. It would store it. Again, this was not something I'd thought of ahead of time, so the name was odd.
Was
wasn't
it
like
transient tables?
No.
Okay.
I feel like it was statement. I think I've just got computed property stuck in my head because that's Django terminology. I don't remember what these were called. It's been a couple of years. But there's a lot of cool things like that you can always learn about with whichever database engine you're using. So if you're struggling to find a good solution, be aware that smarter people than you have come up with a solution for you, and you can go find out what that is.
Yeah, which goes into the next excellent point, temporary tables and views. So the thing you described is sort of an example of a temporary table where you're not actually creating a table, but what you do is you describe every information you want, you store it in memory, so you sort of increase the database memory usage a little bit. But now you have all the information you need prefetched, so that when you're looping over in your normal query on this information, it's not fetching over and over from the subsequent table or a set of tables. It could be just collecting information from all over the place, storing it in this temporary area. You run queries. Once you're done, it throws away all the information.
Now that you've said that, I remember those, and I think I conflated them with the thing I was thinking of, which still I used, but they were like, the thing I used was like a named statement or something. Whereas, yeah, the temporary tables were incredibly useful for that reason, because essentially I need to like aggregate and pre-configure a bunch of data from this separate system that was a mess. Be like, I need to use this in a sane way just for the purpose of ETL, and temporary tables were great for that.
Yeah. And another great use of temporary tables, which most of us probably won't need for the most part, but if you have a lot of information coming in and your database is slowing down because you're writing too many things, so let's say a whole bunch of information is coming in, or you're processing some user event or something big happened, and now you have 100 rows being generated from it. Instead of trying to insert them one by one into this table, because you're probably doing it through code, and that's going to slow down the database. So what a lot of people, or what's the preferred way of doing it, is you insert all of that sequentially in a temporary table, and then you run a database command of saying, get everything from the temporary table, insert it bulk into the normal table, and then trash the temporary table.
Right.
And at least then database handles it, gets it done really quickly, and then your code is all nice and clean, and you didn't hamper or lock the table down because you're writing sequentially like one record at a time. Because it can get pretty hard to configure a bulk insert statement cleanly without locking up the table through code. So another good use for using temporary tables. And that way you're also like reusing database connection pool that you have, instead of individual threads going in, writing single things over and over, locking the things, running out of pool. You do bulk dumps and you let the database handle it on its own end, and things are generally for the better and nicer. And then another thing is views, where you can use a view which is essentially a glorified subquery. You can use a view as a temporary table. The only difference is views cannot be written, and views are they're dynamic. So I can write a view of a query that I really like and use constantly, and then I can just be like, view get aggregated 30-day information about children who are naughty because Santa said so. And I could then select star from it. Instead of having this giant query every single time, I could have a view represent that information. Just remember to update your views every time you update your tables and columns, because they are not dynamic in that way, and it'll make you sad.
Fair enough.
Yeah. Yeah. And if you're using ORMs, which you probably are and should be use checkpoints a lot. I remember, I think it's one of the ORMs in Python whose name I am feeling, SQL Alchemy. Wow. It's been a while. And one of the great things it had was, instead of commit, you can do .save, where the data goes to the database's memory and all your information stays in memory until you hit commit, and that gets written to disk. So for larger data sets, we used save and rollback to ensure either data gets written properly or the entire transaction gets thrown away without exhausting the database connection pools. So if you're smart about how you're using them, it is a huge optimization, which you will notice as more writes happen, and you'll have to like replace your disks less frequently, and a lot of great things which you probably won't notice because you're probably using a cloud provider, but it will help. Just blindly trust me on this.
Yeah, your hardware provider from which you're renting the hardware will have to deal with it, but it's still good to be good.
Yeah, why make their life harder, Why ruin hard drives? Electrical waste is already too much, and if because of you Earth is dying, you don't want to be held responsible.
There you go. Save the planet. Save your commits.
Yeah. Commit less, but often. But not too often, because that's bad for the
sweet spot, the Goldilocks zone of committing.
Yeah. Not too early, not too late. Just like relationships.
Sure. Yeah. You
got to
disagree
figure that.
And then commit.
Just disagree and commit. Exactly. Yeah, and now we're finally at, not finally, I have like 3 more things, but we're at scaling.
Right. Okay. I was hoping that this had been all one query-based section, which is what I
Yeah.
thought it was. Good.
Yeah, I was trying to logically group them. It's like all
Yeah.
the things you can do on the database you already have. You're like, I'm trying to make everything better. I've written good queries. I'm a good person, damn it. Please, why is my database still not as fast as I want? And you know what?
So
It just may be hardware limitation.
I have
Yes, sir.
something to add. So the thing that comes up a lot on my team right now, we're using Django for pretty much everything, in the Python world at least. And if you don't select or prefetch your data so that it knows to get it, then it lazy loads all those foreign keys. And so if you're not specific about what you're intending to access, you can accidentally have many more queries than you thought you did. So you're fetching a user, and then later you reference user.profile. You should have just told it while you're in there, get the user profile, because otherwise it's going to say, oh, I need user profile now. Let me go get that. And then maybe you need something related to profile. It's going, all right, let me go head back and get that. Whereas if you prefetch your data, it's going to be a larger query, but most of the time it's better to have the single query instead of running multiple queries that otherwise could just be batched. So putting just something, again, because ORM syntax is so easy to use, sometimes you can miss things like that. And so something that we have is we'll throw in query count assertions into our tests on particular endpoints, things that we expect could accidentally grow to be like, n+1 query counts. We're like, let's make sure that doesn't happen accidentally. And so oftentimes we have to go in there and be like, all right, it's no longer 12 queries, it's now 13. But that's a whole lot better than the test going from 12 to 1200 because you're fetching that many records, right? So keeping an eye on these things has been valuable for us because otherwise you get these accidental runaway endpoints.
Yeah, no, excellent point. I completely forgot about that one. Loading data using ORMs when you're coding, very, very important because if your queries are good, the biggest problem or the biggest lag you'll have will be network lag. It won't be the disk, it won't be the information, it won't be the RAM, it'll be the distance between you and your database and your servers. So if you load data properly whenever you're making queries relevant to your interests, it will make things a lot more easier and nicer for you in the long run. Even if it's a more taxing query, the complete operation will take less time, which is what you want at the end of the day.
Right. And so another thing about that is not accidentally loading all of that data prematurely.
Yeah.
So if you already mentioned this, but if you can gradually build up a query that includes learning like, oh, did they provide this argument? All right, I'll add a filter, and then doing this step and this step and this step, so that you know this is all the data I'm going to need and not more, then request that from the database. Instead of accidentally loading that data prematurely, you've now got half the table instead of a few rows, and then filtering it in code. You mentioned it already, but just avoid that as an entire subset of potential problems by just seeing like, am I filtering stuff out after I fetch the data? Let's not do that. Let's let the query do that, build up the query. And again, this just happens more typically in something like an ORM because it all feels like the same thing because it's all code. And so that can be a lapse sometimes, especially if you're using like for loops or what am I trying to think of? List comprehension, something like that. You can accidentally load a bunch of data that you didn't really think about because it was a query set and now it's not. It's an actual executed piece of code that is going to load that data. So keep an eye on it.
Yeah. Listen to Nathan. Be more like Nathan. That's a
Woo.
Yeah, huge point. Huge points. All right, let's walk down to the hardware now. So I did all of this, Nathan. Things aren't working. What are my options to scale?
Call the ops team.
Call
at here in operations. Is that not it?
That's 100% it. As somebody in the operations channel who looks at that.
I knew it. So once that happens, what do you do?
Well, I look at two things. Number one is vertical scaling, which is the easiest, greatest thing to ever exist. I throw more money at my machines and they get bigger and they will handle more traffic. Especially if I'm using a cloud provider, it's even better because they handle everything, and all I have to do is just say, you can charge me more, and they just scale it up. So now instead of 32 gigs RAM, I have 64 gigs of RAM, and everything's happy, and children are singing, and I still have my job, even though I just clicked two buttons and are charging the company more money. Um, but there are limits to that. Now, at some point, you have too big of a machine, but it's still not handling information as fast as possible because you're either hitting disk limits, memory limits, or you're hitting network limits, which is very real for really big machines because network cards can only go so much faster and can only, even if you have a really good network card, OSs have limits, softwares have limit on how much network sockets they can access. So you choose the other route. You go horizontal scaling, where you will have multiple servers doing your bidding and doing all your work, and you just distribute it somehow. Now, in databases, the biggest or the most common pattern is you have your write replica, which is also referred to as master, or your read replicas, where everybody just goes in and reads information from. This is the only sort of use case I've seen in CompSci where they don't generally refer to them as master and slaves. It's just master and read replicas because they don't do anything except let you read information. And you would be honestly like amazed how big of a difference it makes just having two different machines, one handling all reads, one handling all writes. With
Yeah.
the coring, with indexing, with how our information is distributed, it's brilliant and it's just magic, just like all of computers and electricity, really. Uh, and yeah, and then the biggest problem there comes is the more read replicas you have, the more now you have to make sure all of them remain in sync, which is where the biggest issue happens, where you'll write something in your master database, and then it has reached replica A, B, and C, but replica D is a little slow because it ate too much glue, and now it can't give you all that information. And for the most part, if you're using a SaaS provider, you don't need to worry about that. They're mostly that's their job. They take care of it. But it's still something to look out for because they can't guarantee 100% uptime and 100% replication.
Yeah, you do need to know if it's synchronous or asynchronous and whether or not what you're looking for can be eventually consistent or not.
Yeah. And you're paying for a lot more computers now. You're paying for the more replicas you have, the more double, triple, quadruple storage you're paying for. So it
And
is,
and replication costs if you're cross region in AWS.
yeah, getting data transferred between different network regions, completely different machines. Yeah, it's gonna break the bill. But you can distribute them based on how you like. You could have regions A, B, and C having information. Some of it might be faster, some of it might be slower, depending on what services are reading from it. So you can design that infrastructure however you would like. And I'll also touch on a little concept there called sharding, which is they use in databases when they have all these different machines on how it essentially just means however you want to distribute your data. You may want to have 6 different databases, all of them attributing to a different postal code or a different range of numbers or last names or however you want to define your databases. And that way, certain databases only handle certain queries. You will hate yourself when you start joining that information. But if you really just want a write-heavy database getting information out, you may want to shard them accordingly and then getting information from an aggregated source. Again, talk to your resident DBA or your technical architect who may have just come in one day drunk and be like, yeah, let's create a database for each one of the alphabets and we'll be good. And now you're joining 26 tables because someone said, how many employees do we have? And now you're screwed. So yeah, just look out for little gotchas like that. Everything has its
Little
pros and
gotchas
cons.
like creating 26 shards in a table for
Yeah.
employees.
Well, he had 15 years of experience, so everybody just listened to him,
Right.
and
Yeah.
nobody
Yeah.
challenged him, and now the company's losing money.
Mm.
Yeah, definitely not a real world scenario. Uh, But yeah, just look out for things like that. They all have their own great little things, but this is how you can start distributing things at the sharding level, or like at the hardware level, sorry. Yeah, and then I'm on to my final database analysis thing, which is
Wow.
the next level is there's almost too many tools out there that will analyze your database logs, your database queries, database information, your hardware even to suggest if you should move to a better or slower thing. I know Postgres keeps records of how long certain queries are taking and if they can benefit from an index, which is crazy. The database itself knows. Just go ahead and create the index for me, please. Why do I have to do all of this work? Uh, but unfortunately, it likes you, so it wants your approval before it does things. So listen to it. And all these other different databases have their own. There's application process management things where you can put them between your code and database, and they analyze the speed at the database level, at the level on your code, the interaction between them, and you can start figuring out the bottlenecks in your code using those.
Also, I forgot to mention this in the query section, but explain analyze are very useful. It'll show you essentially the query plan. And if you're using Postgres, it has explain analyze, which will give you actual times that it took for that to run, which is super useful, especially if you're comparing, like I was, index versus no index. Did it give us the result we want? And you don't have to deploy that and see what happens. You can do a bunch of testing locally and get some idea. Like initially, I had poor quality data that I created, and it got worse when I added the index. And then I tried it on a development server with development data and realized it got way better and found my problem. But I found that out not by trying to guess how many milliseconds it took, but by actually running a query plan and seeing what the query plan said and how long it took.
Yeah, yeah. Use the tools in your databases. Um, don't be like Nathan who creates data that is not relevant to the actual data structure. Be like the Nathan who actually looked at dev database and figured out that his problem was him.
Yeah, yeah. Turns out if you don't need to join because it's all in the same, it's all pointing to the same record, that it always uses the index, and yeah, it was a problem.
It was a problem.
Yeah.
Yeah, and then the final thing I have is whatever database or querying information you're using, they all have life cycle diagrams. Look at them. When you're creating database queries, figure out which database you're using and in what order does it execute the filters, where, sort, and all that information, because that'll help quite a bit. Once you understand the life cycle of how queries run, it just completely shifts how you start writing them, so that you're not crazily just putting your sort statements before your where clause and all those other things. For the most part, database engines figures out the right order on their own, but you also want to be a good coder and write them in the order they should be executed so that they logically make sense to the wider community.
It took me a
Yeah,
second to even realize what you said, putting your sorts before your wheres. I'm like, don't do that. Don't do
exactly.
that. Oh no.
But see, you can't. Some databases will let you just write so long your select and from is in the right order.
Mm-hmm.
Everything else you can just play around with, and for the most part, it'll say okay, and then try to figure out on its own, and that's just bad.
Right.
And
Yeah.
on this show, we don't do bad things. We do good things because it's the do better show, not do worse show.
Right.
Yeah.
Coming soon. TM.
Yeah, that's all I had. That's all I had in my mind. I thought long and hard, and at the end of the day, the database optimization is just a machine. You're the optimizer. You have all the power. Use
Wow.
it wisely.
Wow. That's some deep thoughts.
Yeah, I'll put it on a t-shirt.
All right. Yeah, I feel very empowered right now.
Cool.
Uh, I have nothing to add. I weighed in with my half-baked thoughts as we went.
They helped.
Oh, great.
Yeah.
Great. So now all I have are do better things. Shall
Whoa.
we?
Yeah, what did you do better? What are you gonna do better at?
So at first I thought I had nothing to say about doing better because
You've
essentially
achieved
it's just
everything in life.
exactly I'm at peak Nathan. No, it's because I had all these commitments of like, oh, I'm gonna finish learning Classico on guitar and I don't know whatever else I had written down at the time. And then instead we were driving around and I'd spent the previous weekend hanging out with you guys, and then this past week you were on the island, so hanging out with people again. So it's like, oh, I didn't do anything, but I got some stuff. So one of them is actually spent a ton of time with friends, and especially these days, that's a big deal. So I felt very good about that. Uh, Relevant to this conversation, I started learning more about Postgres architecture and performance. So one of the things I had said previously was I was either going to fully commit to the AWS developer course or switch to learning more about in-depth Postgres things, because I've I've recognized that that is a area that I would like to improve on. And so I tried a bit more to the AWS course and I just can't stay focused. I realize I'm hearing it and not listening because I really don't care. It's not novel enough compared to having just finished the other course. It's a lot of retreading and it's not super relevant to my immediate job. So I'm just struggling to stay focused. So I was like, let's switch gears for a bit, move to databases. So I've been doing some of that and I found some good lectures on them today. So I'll continue with that this week as well. I replied to a bunch of recruiter emails. So that's been a do better before. And it wasn't an intentional do better, but I did my sort of monthly sigh, let's get through these, because I'm still trying to commit to responding to everybody eventually. And I got through maybe half of them, and now some more came in because it's just that time of year, I guess. And I don't know. I think I might stop with a lot of the LinkedIn ones and just at least cover the ones that come through my actual email account, because those ones are always more personable for the most part anyway, whereas LinkedIn's are usually pretty copy-paste. So I mentioned getting to Diamond rank in 2v2 for Rocket League. I got the Diamond season reward because I got 10 Diamond wins, so progress. Again, another thing nobody cares about other than me, but I was still happy about it. And those are all of my did betters. Let's hear some from you, because maybe you can just do the whole thing, because I don't want to keep talking.
Well, I like hearing you talk, so that's a bummer, but I'll move
Well,
on.
good. It's half the show.
It's half the show, pretty much. Well, on my did better, I hiked. I hiked some days more than I wanted to, but I saw some beautiful things, gorgeous views. West Coast has so much to offer, and if I just had friends who would move from little islands to bigger areas, I could see a lot more of it. But it is what it is, and I saw a lot of gorgeous things. I read a little bit more this week, which was kind of nice. A little change from not being able to, like, not having enough attention span to like pick up a book. For some reason, last couple of a month or so, I just can't focus. So I'm happy that's slowly coming back. I think it's because I'm starting to meditate again, which has been helpful. So who knew, right? And yeah, and I just celebrated some friends. It was one of my best friend's birthday this week. He got a kitten, and it's very cute. And yeah, just hanging out, just chilling. Did you want to do your do betters before I do mine?
Yeah, sure.
Yeah.
So I've also got some did not do betters. Right?
Oof.
So
Okay.
I'll do those first. There were two specifically from my list. And the first one's the most regrettable, which was I did not message more girls on dating apps. So that's going right into the do better for next week. And learn more of Classico, which is that Tenacious D song I've been working on. What I did do was I practiced the part I already know and got substantially better at that, because I've been playing guitar pretty much every day since we got back from the drive. And so my do better related to that is going to be learning the next part. So it's kind of a 3-part song. I want to start working on the next part of the song because I think I've kind of maxed out this first part, at least for now. as far as getting comfortable with playing it. So work on that. And then the rest of the do betters, continue learning about Postgres stuff. And I want to do leg day 3 times a week. So right now I'm doing 2. And I've known this every time where I do a 2 to 3 month block most years for the last few years where I do a lot of weightlifting, so snatch and clean and jerk. And my hips, knees, everything always feel really good while I'm doing that block. And I think part of the reason is that both of those weightlifting movements require full squatting, and I do those 4 or 5 times a week in those blocks. And so I think the squatting frequency right now is just a bit too low. Things are starting to feel tight a bit more often. And so I'd like to bump that up. So one of the days will be fairly modest, and it'll just be going through those movements, but intentionally spending time doing more squatting movements. My brain can't decide on motion or movement, so it just comes out as
motion ments.
Yeah, that's right. So that's the other thing, and that should be easy because I friggin' love working out. And that's it.
Neat.
How neat is that?
It's pretty neat. You generally don't see all this neatness in one spot, but
that's right. That's what this show's all about.
That is true. We should just rename it to Do Neat Show. On my do betters, the one at very top I have is, it says do job, which just means work more. I think there's a lot of potential of getting overworked, and I want to explore some of it. So I'm gonna try to do more work because I'm so far enjoying it. Might just be like new job, new fun. Once I actually start hitting roadblocks and getting frustrated, I'm sure that'll come sooner or later. But for now, it's good. So I want to capitalize on it as much as I can. And social media for Do Better is dying, and I feel really bad about it because it's my responsibility. So I gotta ramp it back up and start working on it. I may get some help from a very helpful person, so I need to reach out to her when I start doing all this work. And yeah, it's that's my Do Better for next week. Start fixing the social for this work. And since in the last 2 weeks, I've had maybe 4 hours just to myself. So most of today I had to myself, and I think a lot of tomorrow I'll also have to myself. So I'm going to capitalize on that as well and just hide under a blanket and watch TV, I think. I don't want to hike. I don't want to do anything. I might go to the gym because it is one of my more favorite introvert activities. But yeah, besides that, I'm just gonna make my brain feel like it's good. Um, yeah, you may have mentioned or seen me messing up words and my brain sort of just being tired. And that's just a lot of social interaction. So
well, yeah, we're both struggling to talk a little bit in this episode.
Yes, yeah.
we had very similar weeks.
We'll do better on the next one.
That's right. I did have one thing though. I don't think you've said what team you're on. Are you allowed to say what team you're on?
Yeah, I'm on RDS. So surprise. So I'm on a database team.
That was why I wanted to bring it up. Yeah.
Yes, yeah. I'm allowed to say what team I'm on. I don't think I'm allowed to talk anything about what I'm working on or developing.
Sure.
But yeah, I'm on the RDS team. Everybody seems really cool so far. I'm learning a lot of things about Oracle and how they get mad with their licensing and stuff. Because I'm on the specific portion of Oracle on RDS with the team. But it's really cool because I haven't touched Oracles in like 4-ish years or 5 at this point. And yeah, it's a neat database. That's why enterprises use it. So
yeah, I'm very curious to see how this experience goes for you.
I am too.
You don't intentionally burn yourself out too much.
If I do, I'll just listen to our episode about burnout, which all of you should listen to if you haven't.
There you go. Past you can give you some advice.
Yeah, past us.
I suppose. Yeah, I just said I don't get burned out. I don't know.
That's true. Then again, I just listen to it and just be like, "Ugh, that guy,
That guy, he's the worst.
the worst." Yeah.
All right, I think that's it.
Yeah, go optimize your databases, hit us up with anything you have, and if you also love West Coast, also hit us up, you know. I'll probably put more effort into your Insta if people were talking on it. So do that. This is your responsibility now, not mine. Bye, everybody.
See ya.